This video is sponsored by codingskill.net. Please visit our sponsor. Let's look at Mergesort algorithm. What is the size of the problem? Size of the problem is the length of the list, which is n. What is the base case? The smallest instances occur when n is less than or equal to 1. If so, we return the input list. What is the recursive case? We decompose the problem by dividing the input list in two halves. Two different subproblems of roughly half the size of the original problem have time complexity of O of n log n. Let's look at a concrete example of the recursive thought process. The input is this list. The output is a sorted list of the input elements. In the reduction step, we have a list for the first half and a list for the second half. The first half list, we get a sorted list of these elements. And for the second half of the list, we get this list of sorted elements. In the combine step, we need to merge these two lists together to get the final output. This is a new problem. We had to combine the solutions to the subproblems. Let's now look at the merge sort code. The merge sort method takes a parameter, which is a list. We first find the length of this list and we check if it is less than or equal to 1. If so, we return that particular list. This is the base case. Otherwise, we have a recursive call on the first half of the list and we capture the output of the merge sort in the variable a1. a1 contains list of sorted elements for the first half of the given input. We make another merge sort recursive call for the second half of the list, and the sorted list of elements is captured in the a2 variable. So the second half is now sorted and is in the variable a2. We then merge these two sorted lists to form one list that gives the result for the given input list. Let's consider these elements in an array. The first half and the second half are given as input to the merge sort routine. This is the recursive calls made twice for each half of the list. The output of the merge sort is a sorted list of the first half, and on this side we get a sorted list for the second half. These are the output from the merge sort routine, and these are sorted lists, and we can merge this by feeding these lists into the merge method. So we have two inputs going into the merge routine. Output of the merge routine gives a sorted list of all the elements. This is a sorted list. Let's look at the performance. What is the runtime cost? Runtime cost can be expressed by this equation. This is the time taken for the merge sort, and this is the time taken for the merge function. Let's look at the merge method. What is the size of the problem? Size of the problem is given by the minimum length of one of these arrays, A and B. What is the base case? Solution to the problem: if one of the lists is empty, is the other list. Let's now look at the problem decomposition step. We reduce the size of the problem by a unit by discarding the smallest element in either list. List is sorted so it appears in the initial position. Let's look at the code for the merge function. The merge method takes two parameters, and these two are the lists that you want to merge into one list. If list A is empty, we return B. If B is empty, we return A. Otherwise, if the first element in the list A is less than first element in the second list, we put the smallest element that we found in A in the beginning of the list, and we add this to the output of the recursive call that reduces the input by discarding the first element of the list A. Otherwise, we take the element from B, which is smaller, and we add this to the output of the merge recursive call, and B is reduced by 1 by discarding the element in B because we have already processed it. How about the performance? Let's look at the runtime cost of merge function. It's given by this equation, and the time complexity is given by O of n log n for merge function. Sign up for your free coding interview coaching call. Sign up for your free coaching call by going to codinginterview.coach.